Hi, in this video we will go over one of the questions one of the questions of the review exercises for exam number 1. In this problem, we're asked to define some prolog data structures to work on the solution of this type of logic puzzle that is similar to the one that we were doing in class and in the assignment. Now, it is very important that you make the definition of a structure that you're going to be able to manipulate and work with later. So then there are multiple options to define a possible state in here. So in this case, we have 4 people crossing and there is only room for 2. So a valid transition from one state to another is moving 2 people from one side of the river to another side. And now, in addition, there are some constraints that says times in taking a person to the other side. Okay, so we need to be able to have a structure that determines that that also has the times. So one of the ideas that I have in the way that I will program, I can probably call it a state like this, torch, and then I can say that initially I could say that maybe this is the the elements of the list can be the first element. So I'm going to have a list of length 4, and the first element will represent the side of in which side of the river is person A. So I can say I can define that is left and right in the river of west and east. So I can say L. So this is a lowercase l, even doesn't look like lowercase l. So in my representation, I'm saying that person A is in the left, and this is what I will consider in my programming the position in which side of the river for this each one of them. Now I know, but I'm not putting that on here, I know that this takes a minute, this person takes 2, 5, and 8. So I need to take that into consideration later when I'm doing, for example, my heuristic function. Okay, so this may be a way of representing if I'm able to interpret. So this is A, B, C, and D. Now it says if I continue using this data structure, what will be my final state? So the final state, then I can say R, 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 R. So from here I want to go over here. Now what will be a possible rule that may be valid? So I can define maybe move. I can name the rule like rule number 1, and then I can say that this is torch, and then torch maybe has the state L, 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 and then one valid transition is to move any one of these 4 into the right side. So could be R, R, then L, L, and this can be one of my rules. So this is okay. Now what will be an example of a heuristic function? So the idea of the heuristic is that we can judge each one of the possible transitions. So if I do 1, let's say heuristics on 1, and give me that answer in R, then we can say, okay, by moving this person here, this is 1 and the other is 2, then it says that I take the person that is this lower person time, so that will be 2. Then my R, I can say R is 2, but I say previously, I mean, this is okay, but if this is what I have in the transition, I can basically say this for 1. Instead of saying this, with this is fine, I could say this, so this is even better. So I have, if I'm asking for what will be the time I'm doing this transition, this will be maybe a definition of my function, and we don't really need this. Now for question 2, maybe you can also have multiple ways of solving this, but this is the information that we got. We got a graph, and then we got a lot of information from this graph, and then it says, okay, let's suppose that we start here, and then from here I want to reach a goal. But in this example I have multiple goals, so I got goal 1, 3, and 2. So by following one of these algorithms, we want to see what will be the agenda or the visits, and which of the goals is the one that I will reach. Like for example, if we do breadth first search and we start here, also depends how we program the paths, because we need to visit one of the children of S, which is A, B, or D. And if we program in Prolog that this is the first that we're going to find from top to bottom in the program, then this is the first one that we visit, regardless of that 5 and that 7. And then from here we go with one of the children, whoever is the one that has been programmed, and then maybe we go to G, and then we finish. That's a possibility. Now you're doing I'm sorry, that was that first search. So that first search was from S, I went to A, and from A went to G. If I'm doing breadth first search, we go with the 3 children first, right? So I visit A, B, and D, and then I visit each one of the children of A, B, and D if they haven't visited, until I reach one of the goals. And in those first 2, you did not use a heuristic function. In this, you just consider, once you are here, you take into consideration these times, right? And then you go with the one with the smallest time. And for A star search, what I want you to do is, in the heuristic, you consider not only the current distance, but what is it, the prediction. So each of the node contains an estimated cost to the goal. So you add those 2 numbers to do the computation. So I think I can trust on the answers that you can get me this, but I think this review will help you to remember what to do.